Hello viewers, my name is Dr. Ajay, Associate Professor, Department of ECE, Institute of Aeronautical Engineering College, Hyderabad. Today we are going to discuss the topic on problems on arrays of two isotropic point sources having equal amplitude and phase. So today's topic is problems on arrays of two isotropic point sources having equal amplitude and phase here. So this topic is related to our course Antennas, Waves and Propagation. So this topic is related to the course Antennas, Waves and Propagation. So let us start our session today. Find the E field pattern of the arrays of two isotropic point sources having equal amplitude, lambda by 4 spacing and a phase difference of 90 degrees. So plot the E field pattern of two isotropic point sources having equal amplitude, lambda by 4 spacing and phase difference of 90 degrees. So here, as we have seen in the theory of the two isotropic point sources, an isotropic point source is nothing but it is a source which radiates uniformly in all directions. So we have seen in the earlier theory classes that what is the electric field equation, what is the electric field produced by two isotropic point sources having equal amplitude and phase. So but here the phase difference is given as 90 degrees. But we have derived the expression for same phase. We have derived the expression for same phase. So here we are going to take the same expression and we are going to substitute the value of phase difference in that expression to find out the E field pattern. So E field pattern is nothing but we need to draw the radiation pattern. We need to draw the radiation pattern for the array of two isotropic point sources. So let us do the solution for this problem. We know that E is equal to 2E naught cos psi by 2. We know that E is equal to 2E naught cos psi by 2. So here psi represents the total phase angle. Psi represents the total phase angle of all the elements in an array. So we know that the value of psi is equal to beta d cos theta. The value of psi is nothing but beta d cos theta. But according to the given problem, the data, the spacing between the two elements, it is given as d is equal to lambda by 4. So as per the given data, the value of d is given as a lambda by 4. So we can also include alpha here, the phase difference as 90. So psi, the difference between the psi and alpha is, psi means the total phase angle, produced by all the elements of an array. But alpha is the phase angle produced by each individual element, between two individual elements in an array. So psi is the total phase angle of all the elements in an array, but alpha is the phase angle produced by each individual element of an array. Here alpha, it is given as 90 degrees, or we can also simply write as pi by 2 here. So if we substitute these two values, we will get the value of psi. Psi is equal to beta d. Beta is nothing but the propagation constant, which is given as 2 pi by lambda. So beta is equal to 2 pi by lambda into d is nothing but the spacing, it is given as lambda by 4, and cos theta plus alpha, it is pi by 2. So here lambda get cancelled here, and psi you will get 2 ones 2 2s, you will get pi by 2 cos theta plus pi by 2. So psi is equal to, we got here as pi by 2 cos theta plus pi by 2. So if we simplify this as psi by 2, divide both sides by 2 here. So if you simplify, you will get, dividing both sides by 2, you will get pi by 4 cos theta plus pi by 4. So here psi by 2 is equal to pi by 4 cos theta plus pi by 4 you will get. Now here we need to find out the value of E here. To draw the radiation pattern, we need to find out the value of E here. So what is the value of E here? So E is equal to 2E naught cos psi by 2. So E is equal to 2E naught cos psi by 2 here. So if you simplify this E values, we know that the cos psi by 2 value is pi by 4 plus pi by 4 cos theta. The value of psi by 2 is nothing but pi by 4 plus pi by 4 cos theta. If you simplify this, you will get E is equal to 2 E naught cos of pi by 4 plus pi by 4 cos theta. Let us assume this normalized E norm, that is a normalized function. By assuming the total value of 2 E naught, the maximum value of 2 E naught as 1, you will get E normalized, that is the normalized electric field is given as cos of pi by 4 plus pi by 4 cos theta here you will get. Now here we need to find out the value of E for different values of theta. For different values of theta, so we need to find out the E value. Let us draw a table here. Assume this as theta, assume this as E here. Now in this equation, let us substitute the value as 0 here. For theta is equal to 0. So if theta is equal to 0, what you will get? Cos 0 is equal to 1. So here you will get pi by 4 plus pi by 4. This is equal to cos of pi by 4 plus pi by 4 is equal to 2 pi by 4 here. So 2 1s, 2 2s here. So this is equal to cos 90. So cos 90 is equal to 0 degrees. Now substitute this 0 degrees here. So the value of E is 0 here. So for 0 degrees, you are getting the value of E as 0 here. Now similarly, let us substitute the value of theta again as 90 degrees. If you take the theta as 90 degrees, what you will get? Take this equation, cos of pi by 4 plus pi by 4 cos 90. So for this value, you will get cos 90 means 0 here. So cos 90 means 0. So if you simplify here, you will get cos pi by 4. So cos pi by 4 is nothing but 1 by root 2. Cos pi by 4 is nothing but 1 by root 2. So you will get 1 by root 2 here. Now similarly, you try it for 120 degrees. Let us try for 120 degrees here. So if you try for 120 degrees, if you substitute the value of theta as 120, you will get, if you simplify, cos of pi by 4 plus pi by 4 cos of 120 degrees. So here you will get cos of 120 means you will get cos 90 plus 30 minus sin 30. So minus sin 30 means minus 1 by 2 you will get. So here this value is, you will get minus 1 by 2 here. So minus 1 by 2 into pi by 4, if you simplify here, you will get minus pi by 8. You will get minus pi by 8. So pi by 4 minus pi by 80 you will get. So 8 pi minus you will get 8, 2 pi minus pi, you will get pi by 8 here. So cos pi by 8 value, it is nothing but it is 0.94. It is 0.94 degrees. Similarly, if you simplify the value of theta as 150 degrees, substitute here in this function, theta is equal to 150 degrees here. If you simplify for 150 degrees, and if you calculate the value of E, you will get the value as 0.99 here. You will get the value as 0.99 here. And similarly, if you simplify the E value by taking the value of theta as 180 degrees, so you will get here 180 degrees. For 180 degrees, you will get 1. For 180 degrees, you will get the value as 1 here. So based upon this data, based upon the value of theta and E, we need to draw the radiation pattern. So here, you can observe here the radiation pattern. So here the value of it is theta here. The theta is, this is the value of E here. So 0 degrees, 0. And for 90 it is 1 by root 2. For 120 it is 0.924. And for 150 it is 0.994. And for 180 degrees it is 1 here. So based upon the data, we know that we are going to represent as this is 0, this is 90, this is 180, and this is 270. This is 270. So here this is 0 degrees, this is 90 degrees here. So for 0 degrees we are getting the value as 0 here. The starting point is 0 here. And for 90 degrees, it is 1 by root 2. So 1 by root 2 is nothing but 1 by root 2 means 1.414. You will get approximately 0.707, something like that. So 1 by 1.414 means you will get 0.707 like that. So here, when the value of theta is 90, so you will get 0.707 here. So approximately you can draw. You can take this as 1 unit here. This is as 1 unit, and this as 1 unit, and this as 1 unit here. 1 centimeter. 1 centimeter is equal to 1 unit. So based upon the data, 90 means you will get 0.707. So let us assume this is 1 unit. This is 1 unit, and this is 1 unit. 0.707 means you will get here. Okay, and similarly for 120 degrees. So for 120 degrees, this is 120 here. This is 120, and for this 120 also let us take 1 unit means like this 1 unit. For 120 you will get 0.9 here. This is 0.9 here, and this is 0.7 here. Okay, and for 150 you will get here you will get 0.994 here. 1 unit. 1 unit means 1 centimeter. So 180 means 1 here. So this is 1 approximately. So like this, if you join all these points here, you will get like this. So you can find out more number of values of theta, so that you will get the value of E, clear radiation pattern. So more values of theta, you will get more values of E, so that the radiation pattern will be clear. So we have taken here only 5 values. So we are getting only this side only, the radiation pattern. And we can also take 5 more values for minus 90, for minus 120, for minus 150, and you will get the radiation pattern like this. So like this, this is the how to draw the radiation pattern. So let us repeat again. So how to draw the radiation pattern here, you will see here. See here, let us say the how to draw the radiation pattern here. This is the x-axis and this is the y-axis here. Assume here as 0 degrees here. Assume here this has 0 degrees. This is 90 degrees here. This is 180 degrees. And this is 270 degrees. Okay, and assume this as 1 unit. And this has 1 unit. And this has 1 unit. And this has 1 unit here. So 1 unit means 1 centimeter. And let us assume here this has 1 unit for 120 degrees. And this as 150 degrees. This is 1 unit here. So let us assume all these points indicates 1 unit. All these cross points. This cross indicates 1 unit, that is equal to 1 centimeter. Now for 0, we are getting what is the value of 0 here. So for 0 it is 0 here. So this is 0 here, the first point. Okay, and for 90 it is 1 by root 2. So 1 by root 2 is 0.707. So this is 0.707 here. So for 120 we got 0.94. So for 120 we got 0.94, you will get here. For 150 degrees we got 0.99. So 0.99 means you will get here 0.99. For 180 degrees it is 1 here. So this is 1 here. So like this, if you draw the radiation pattern, you will get, if you join all these points, you will get like this. Okay, so this is the point marked as 1 by root 2 here. This is 0.94. This point is, and this point is 0.99 here. And this point is marked as 1 here. So by joining all these points, we can draw the radiation pattern here. Okay. So this is the radiation pattern we got here. Now let us do the second problem. There is plot the E field pattern of the arrays of 2 point sources having equal amplitude, lambda by 2 spacing and phase difference of 90 degrees. So here the difference between the previous problem and this problem is, the previous problem is given as the spacing as d is equal to lambda by 4, but here the spacing it is given as lambda by 2 here. The spacing it is given as lambda by 2, but the phase difference is same, that is 90 degrees here. So based upon the D, we'll see how the radiation pattern will vary. How the radiation pattern will vary, we'll see by simplifying the value of E. Again, we shall take the value of E. E is equal to 2 E naught cos psi by 2 we know. What is psi here? The psi value is the total phase angle. The total phase angle of all the elements of an array, we call it as a psi. And alpha represents psi is equal to beta d cos theta plus alpha. Alpha is nothing but the phase angle of each individual element of the array. What is beta? It is 2 pi by lambda. It is the propagation constant. Here the spacing d, it is given as lambda by 2 here. Cos theta, write it similarly. And alpha is given as pi by 2 here. So if you simplify this, lambda lambda get cancelled, 2 to get cancelled, you will get pi cos theta plus pi by 2. So this is the value of psi we got. So what is psi by 2 here? Psi by 2 is nothing but it is pi by 4 plus pi by 2 cos theta. So we simplify this E is equal to 2 E naught cos psi by 2. So what is the value of psi by 2 here? It is pi by 4 plus pi by 2 cos theta. So for this function, if we normalize, you will get E normal is equal to cos of pi by 4 plus pi by 2 cos theta. So assuming 2 E naught as 1. Assuming the E naught where the maximum value of amplitude is taken as 1, that is 2 E naught is equal to 1. So for this function, we need to find out the value of E for different values of theta here. For different values of theta. So we got E is equal to cos of pi by 4 plus pi by 2 cos theta. So E is equal to cos of pi by 4 plus pi by 2 cos theta. So let us draw a table here. Let us draw a table here. For different values of theta, let us find out the values of E here. For theta and E here. So here, let us substitute the theta as 0 here. If you substitute theta is equal to 0 here, what you will get? Cos of pi by 4 plus pi by 2 cos 0. This is equal to cos of cos 0 is 1 here. If we substitute this 1, you will get pi by 4 plus pi by 2 here. So if you simplify here this here, you will get 4 ones 4 plus 2 pi. So this you will get cos of 3 pi by 4 here. 3 pi by 4 here. So if you simplify this value, you will get 1 by root 2. This is 1 by root 2 here. Now similarly, let us take the theta value as 60 degrees. Let us take the value of theta as 60 degrees. Now again, if you simplify E, you will get cos of pi by 4 plus pi by 2 cos 60. So what is cos 60? Cos 60 is 1 by 2. So cos of pi by 4 plus pi by 2 into cos 60 is 1 by 2. So this is equal to cos of 2 into pi by 4. 2 into pi by 4. So 2 ones and 2 twos you will get cos 90. This is equal to 0 here. So E is equal to 0 you will get. So for different values of theta, we need to find out the value of E here. For different values of theta, we need to find out the value of E. For 90 degrees, you will get 1 by root 2 here. And for 120 degrees, you will get the value as 1 here. Just substitute the values of theta here by varying 90 and also for 120. Simplify. You will get for 180 degrees, you will get 1 by root 2 here. So for this table, for this data, what we got the value of E and theta, we need to draw the radiation pattern here. See here, you can see the radiation pattern here for the data here. Here theta and this is E value. So 0, 60, 90, 120 and 180. For this you will get 1 by root 2, you will get 0, Again here 1 by root 2 here. This is 1 and this is 1 by root 2 here. So for this, if you draw the radiation pattern, this is 0, this is 90 degrees, this is 180 degrees, and this is 270 degrees. Let us take this as 1 unit, this as 1 unit, and this as 1 unit, and this as 1 unit. Also, this is 120. Let us take this as 120 here. This is 120, and let us take this as 60 here. This is 60 degrees. So for this, if you draw the data here, for theta value as 0. So here theta is equal to 0 degrees here. So when theta is equal to 0, we got 1 by root 2 here. So when theta is equal to 0, you got 1 by root 2 here. So this is 1 by root 2 here. And our theta is equal to 60, we got 0 here. We got 0 here. That means we are getting one radiation pattern like this for these two values. For value of 0 and 60, we got a minor lobe. We got a minor lobe here. Similarly, for 90, it is 1 by root 2 here. This is 1 by root 2 here. This is 1 by root 2. And for 120, it is 1 here. This is 1 here. And for 180, it is 1 by root 2 here again. This is 1 by root 2 here. And if you draw the radiation pattern, you will get like this. So this is how to draw the radiation pattern separated by a distance of d is equal to lambda by 2. So when we see the problem 1 and problem 2, so here you can see here, when d is equal to lambda by 4, we are getting a radiation pattern like this. But when d is equal to lambda by 2, we got a radiation pattern with a minor lobe. So when d is equal to lambda by 4, the minor lobes do not exist. When d is equal to lambda by 2, the elements between it is increased. When the spacing between the elements is increased, we are getting the minor lobes here. So we need to design an antenna in such a way that the minor lobes must be decreased. The minor lobes must be decreased to a greater extent. So then only the antenna performance will be effectively. Right? The performance of the antenna can be increased only when the minor lobes are very less here. So when d is equal to lambda by 2, we have observed minor lobes. When d is equal to lambda by 4, there is no minor lobe. So like this, we can change the values of d till the minor lobes are eliminated. So here let us the references for this the references for this data is problems is antenna space and propagation by U.A. Bakshi here, and also we can refer the textbook K.D. Prasad, that is antennas and wave propagation, taking a publication first edition 2001. So for more problems you can verify John D. Cross. For more problems you can verify John D. Cross, or you can also verify the Balanis textbook for more number of problems. You can refer Balanis antenna space and propagation and also John D. Cross. So let us close our session today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.